Hello kids, thanks for watching this video on the derivatives and the integrals of inverse trig functions. This is something we haven't really talked about at all this year, but it's going to start showing up a lot more frequently as soon as we get back from break. So it's something we definitely need to know how to do before we continue on. Okay, so it's just, unfortunately, more memorization of rules. At first glance, it looks like there's 6 rules, but there's actually not. There's only 3 rules: sine inverse, tangent inverse, and secant inverse. And then the opposites of those. And it seems like I'm missing that one there, kind of almost disappeared. But these are the same, these are the same, and these are the same, just with a negative sign out in front. Okay, so really we're memorizing 3 rules and their opposites. And if we're using chain rule, which, let's be honest, most derivatives at this point involve a chain rule, basically you're just going to multiply by the derivative of u. Okay? So let's take a look at a couple examples. The first one says arc sine of 2x. Now remember, we can also think of this as sine inverse of 2x. And really all we're going to do here is apply this rule right there. Okay, well actually I guess it would be this one right here because we are using chain rule. So it's going to be 1 over root 1 minus, u would be just 2x here. So 2x squared times the derivative of u, which is 2. Let's make this a little bit smaller here. So if we simplify that, we would just simply get 2 over root 1 minus 4x squared. Question B, tangent inverse of 3x, the derivative of that. So we're going to use this rule right here. That's going to be 1 over 1 plus 3x squared times 3. Or 3 over 1 plus 9x squared. Question C, tangent inverse of root x. We're going to use that same rule right here. So it's going to be 1 over 1 plus root x squared times the derivative of root x, so 1/2 x to the negative 1/2. All right, and cleaning that up, we should get 1 over 2 times 1 plus x squared times root x, or x to the 1/2 if you prefer. I'm sorry, this is not squared. Root x squared is not x squared. Root x squared is x. All right, tricky one here is it's going to involve a couple chain rules. Okay, so the outermost functions is squared. So our first link in the chain is going to be 2 secant inverse e to the 2x. Then we're going to apply this rule here. Okay, so it's going to be times 1 over absolute value of u times root u squared minus 1. Okay, and then times chain rule times the derivative of u. So that would be times 2e to the 2x. So that's our answer, and that's a fine answer. There's nothing wrong with that answer. Before I clean it up a little bit, we can get 4e to the 2x secant inverse e to the 2x over absolute value of e to the 2x, which that's always going to end up being a positive number anyway, so we can drop the absolute values. Root e to the 4x minus 1, and then these could cancel out here, and that would give me 4 secant inverse e to the 2x over root e to the 4x minus 1. Now this is only something you're going to want to do if this is a multiple choice question. If it was a written question, I would highly suggest to leave it right there. All right. Now let's go to the other direction, integration. And this is honestly where I see this come up a whole lot more. I don't see a lot of derivatives being used in the AP world, but for antiderivatives, I definitely see it coming up quite often. And really, I said last time we only need to memorize 3. There really is only 3 this time. Now, these 3 are the same, just in case x isn't just x, it's some type of function. But it's just 3. All right, why? Because if they were negative, they would still be the same thing, just the opposites of it. We don't need the other 3. We don't need cosine, cosecant, or cotangent. All right, so let's take a look at 4 examples here. 2a, I'm going to start by just rewriting this as the integral of 1 over root 1 minus 2x squared dx. All right, now it's all about recognition. Right now, hopefully we could recognize, oh, this is the sine inverse integral, because this would be the derivative of sine inverse. Okay? If I can do that, then I know that my a must be 1, my u must be 2x. And du would be 2 dx, and 1/2 du would equal dx. I can rewrite this as 1/2 antiderivative 1 over root 1 minus u squared du. And now I can use that rule right here. Arc sine u over a. So arc sine u over a plus c. And don't forget to re-substitute back in. U was 2x, so it'll be arc sine 2x plus c. Okay, second one, hopefully we could recognize this. As 2x squared minus 3 squared, right? So hopefully you recognize this as the secant inverse antiderivative, all right? So you can see it right there. Okay, so let's take a look at what we got here. U is going to be 2x again, and then a would be 3. So then du would equal 2 dx, 1/2 du would equal dx. And if we substitute back in here, we would get 1/2 antiderivative of 1 over that x. We'll have to take care of that in a second. We'll fix that in a second. Of u squared minus 3 squared. So what would x be then? U over 2 would equal x. So I can put 1/2 u right here. Du. All right, and these 1/2s will cancel out. So those will be gone. And now we have essentially what looks exactly like the secant inverse integral. All right, so our antiderivative is going to be 1 over a arcsecant, absolute value of u over a plus c. And then don't forget to resubstitute back in. U would be 2x here. And there we have it. And 2x is not always positive, so you got to keep those absolute value bars there. All right, question C. Hopefully we recognize this as an arcsine integral. This one's actually pretty straightforward here. A would be 2 and u would be x. So we really don't have to do any substitution with this. We can jump straight to the final answer here. Arcsine of u over a plus c. No point in substituting u for x. It's just a changing of a variable. That's it. So don't bother. Okay, and the last one. Hopefully we can think of this as 1 over root 2 squared plus 3x squared dx, where a is root 2 and u is 3x. So then du equals 3 dx and 1/3 du equals dx. So now I can write this as 1/3 antiderivative of 1 over root 2 squared plus u squared du. So this is going to be 1/3, and then the antiderivative tangent, tangent inverse, right here, 1 over a arctan u over a. So 1 over a arctan u over a plus c. And then make sure you resubstitute. So 1 over 3 root 2 arctan 3x over root 2 plus c. Okay, so like I said, that's kind of antiderivatives are going to come up a lot in the next couple chapters here. So it's important that we can recognize them and know how to find them with ease. All right, thank you very much for watching my video on this, and I'll see you soon.